In this video, we're going to talk about solving linear systems. And so first I'll start by defining what a linear equation is. And when we talk about an equation, a linear equation, anything that is linear, the word linear has the word line in it. So we're going to be dealing with a whole lot of lines here. And so when we graph these equations, it's going to look like lines. And generally speaking, a linear equation is any equation that has the highest, what we call the degree, or when you look at the exponent, it's going to be a 1. And so generally you won't even see an exponent when you talk about linear equation. And we're going to find solutions to these equations algebraically. And the solution just makes the equation true. So we want to see what value is going to make the equation true. And so when we look at this first one, all we're going to do is solve equations. And when we solve equations algebraically, remember we're reversing the order of what we call PEMDAS, which is parentheses, exponents, multiplication, division, addition, and subtraction. So we're going to reverse that order. And in a couple of these problems, what we're going to do, if we see numbers in front of symbols like this tells us we need to distribute. So we see numbers in front of parentheses, we need to distribute. And then we're going to distribute first and go ahead and solve from there. Solving means to isolate. We're going to isolate variables here. So when we try to solve, we want to isolate whatever that variable is. So we look at this first equation. We have the equation 3 times x minus 8. That's equal to x plus 4. So notice I have variables on both sides of the equation. I need to get the variable on one side to be isolated. So the first step in this is to look at the number in front of the parentheses and distribute it. So we're going to distribute. That means we're going to multiply both numbers inside the parentheses by the number in the front. So when we do that, we get this here. 3x minus 3 times 8 is a negative 24. That's equal to x plus 4. Again, the goal is to isolate the variable x. So to isolate the variable x, in order to do that, I need to move x to one side. And I'm generally going to move x to the side where the x's are bigger at. And to do that, I'm going to always do the opposite operation because I'm undoing processes here. So I want to move the x to this side over here because it's bigger. So I'll subtract an x on this side and an x to this side. And remember, I'm undoing this, so this will cancel it out. And 3x minus x is 2x. Minus 24, that's equal to a positive 4. And so from here, the next step is to get x by itself. So I want to isolate this variable here, isolate x. So to do that, I'm going to undo this. So minus 24, undo it. I'm going to add 24. And from there, I'm going to notice that these are going to cancel. And here's what I'm left with. 2x on this side, that's equal to 24 plus 4 is 28. And again, last step, undo the operation. So I want to undo the multiplication that's taking place here by dividing by 2 on both sides. And this tells me that x is equal to 14. And so what that means is that when I plug 14 in for any x in this equation, it should make the equation true. You can verify that. Plug in 14 here. 14 minus 8 is 6. 3 times 6 will be 18. Plug in 14 here. 14 plus 4 is 18. So we can see that 18 equals 18. So the correct solution here is 14. So in this next one, let's do one more like it. First thing we're going to do, again, we see the grouping symbol. So we see the grouping symbol. So our first step, again, is to distribute. But notice we're distributing a negative here. We're distributing a negative here. So it's going to change the signs inside of there. So we're left with 8x minus 5x plus negative times the negative is a positive plus 5 equals 20. And then from there, I want to isolate, or I want to combine like terms now over here. These terms are alike, so I can combine them. So it leaves me with 8x minus 5x is 3x plus 5, that equals 20. Isolate x. So I want to isolate this variable x. To do that, I'm going to subtract out 5 on both sides. Undo the addition that's taking place there. So that's 3x. 20 minus 5 is equal to 15. Get this x by itself. It's multiplying, so I'm going to divide it by 3 on both sides. And I get x is equal to a positive 5. And again, I can go back and check that by plugging in 5 into the equation for every x. 8 times 5 is 40. 5 minus 1 is 4. So that'll be a negative 5 times 4, which is 20. So that'll be 40 minus 20, which is 20. That should equal 20. That is correct. Solution set.